Welcome back. Today we have this problem. It's called intersection of two arrays. We have given two arrays, nums and nums1 and nums2. Return an array of their intersection. Each element in the results must be unique, and you may return the results in any order. So, for example, we have one nums1 has 1, 2, 2, 1, and nums2 is 2, 2. So the intersection is 2 because the most common element is 2. For this one we have 4, 9, 5 and 9, 4, 9, 8, 4. So the intersection is 9 and 4 because it's the most common in between these two arrays. So how can we solve this problem? Let's go to the board. So there is two ways coming to my mind. One, we can just loop through the first array, the smallest array, because we will not find the most common, so we have to go to the smallest array. We can go with the biggest one also, but like for performance reasons, we can go with the smallest array, and we can just for each element we'll start to compare this element to all of the array. So like we'll do it 3 times, and the time complexity will be O of n multiplied by m, whereas n is the length of the nums1 and m the length of num2. And I guess there is a way that we could do this way more better. Let's say that we create 2 sets, okay, sets for this one, and we create sets for this one, okay, and we start to we create sets based on this array. So for this example the sets will be 4, 9, 5, because it sets is a unique it only accepts unique IDs. And for this one it will be 9, 4, we don't 9, we don't take, and 8. And we start to compare them. Maybe we could just start with the smallest one, as we said before, the same. And we start to compare them, like for this one, for this element, this element has this one. If yes, push it to let's say that we create a results array. So push it to the results array. So results array will have 4, and we go to 9. Is 9 is there? Yes, we can use the has method. It's just pretty straightforward. Yes, if it's yes, okay, push it to this array. If 5 in this array, no, okay, don't do anything. So we have 4 and 9, and we just return it. So yeah, that's it. So let's just start to have the, and the time complexity, it will be O of n plus m, not O of n multiplied by m. So I will say I will create let's set 1 equals new set of nums1, and let's set 2 equals new set of nums2, and I'll say if, as we said, if set the size, because we want to start with we want to compare all the time with the smallest, because there is no need to compare with the biggest one. We will go through a lot of elements that is not even there. So if set of size 1 is less than set 2 of size okay, I will loop through set 1 and compare it to set 2. Else I will loop through set 2 and compare it to set 1. So I guess let's create, I will create this function because I don't want to duplicate my code multiple times. So I will set return this array, this function, and this function will have set 1 and set 2 else it will be the same, but it will be set 2 and set 1, set 2 and set 1, to make sure that we only have the smallest. And I will create the output, and this output will be an empty array, and I will return this output and let's start into the function. I will make a loop, let s of set 1 sorry, and I will say if set 2 dot has s output dot push this is okay. I know I'm beating a lot. Let's talk about how this works. First of all, as we said, that we create a set 1 and set 2, and the important thing about the set, that we make sure that the elements are in the set are unique. And after that, we have we wanna loop by the smallest, because there is no need to loop by the biggest one. So we create this function, and this function creates the set 1 and set 2, and basically it's compare them. It's really straightforward one. And that's it for this solution, for today's problem. I hope that my solution was quite good. If you like my content, make sure to subscribe, hit the notification bell so you will never miss a video, and see you in future problems.